Hi, welcome everyone. Good morning. Welcome to the class 3171, the pre-calculus one. Okay. So we have pre-calculus 1 and the pre-calculus 2. And this is a pre-calculus 1. Okay, so in this class, we are going to use the textbook. Let's see what this is. This is a textbook. The Sullivan's Algebra and Trigonometry, 9th edition. Okay, so you can find this textbook online. There's an electronic PDF file. Okay, so the textbook. Sullivan's Algebra and Trigonometry. Okay, so that's 9th edition. Okay, so the sections covered by this course are already listed in that Bosquejo file. So you can just check that Bosquejo file. If you have question, we can answer that. And for this semester's course, we plan to have 3 exams, 3 partial exams plus 1 final exam. So we will totally have 4 exams. So 3 partial exam: partial exam 1, partial exam 2, and partial exam 3, and plus a final exam. In that Bosquejo file, we already put the dates for 3 partial exams. The date for the final exam is to be determined, so we still don't know the date of the final exam. We will discuss it when we are close to the end of the semester. Okay, so we have 3 exams, 3 partial exam and 1 final exam, and final grade. So how do we calculate the final grade? Here is the formula. So we will add 3 partial exams, and we're going to double the final exam. So you have 5 numbers, and among those 5 numbers, we are going to subtract the minimum number among it. So the minimum among them. So basically, we will drop the minimum grade you have among those 5 numbers. So since we drop it, you have 4 numbers. We divide it by 4. Okay, so it's like 400 over 4. It's still 100. And we have the following scale. If you have 85 and above, you will get A. If you have 75 to 84, you will have B. If you have 65 to 74, you have C. If you have a 60 to 64, you have D. Of course, if it's below, if it's up to 59, it's F. Lower than 60 is F. Okay, so this is the grade. Above 85, A. Between 75, 84, it's B. Between 65, 74, it's C. Between 60, 64, it's D. Below 60 is F. It's F. Okay, so before each partial exam, there will be a practice exam. Okay, So before each partial exam, you will see a practice exam. The practice exam will be very close to the real partial exams. But before the final exam, there's no practice. So your partial exam plus those practice exams will be the practice for the final exam. And the final exam will cover all the material discussed during the whole semester. Okay? So final exam will cover all sections discussed in the semester. Okay, so that's the big picture about the exams. In that Bosquejo file, we also have the recommended exercise for each sections. You will do those exercises, but you will not turn them in. So if you have a question about your exercise, you can send email and I will explain it. But in general, I do not collect practice. I do not collect exams. And for the practice exam, I will provide the answer key. So I will provide answer key before the real exam. So before the real exam, you should be able to know how to do the problems in the practice exam. Okay. And for the partial exam and the final exam, here is a strategy. How do we process of exam? So the exam will be delivered through the email, your university email, 10 minutes before the exam time, exam hour, and you're supposed to turn on your microphone, turn on your camera. You will join some Google Meet link. You will join some Google Meet. I will give you that link during the exam, before the exam. So you will join that Google Meet, and I should see you through the camera. I should be able to hear you through the microphone. Okay? So you need to prepare for that. Except the exam, I don't need you to use the camera and the microphone. Okay, so you can use YouTube to download the file, download the video, or you just watch the video on YouTube. It's not the problem. But during the exam, 3 partial exam plus a final exam, you must have a camera and you have a microphone. I should be able to completely see you through it, well, for the monitor purpose. Okay, so that's our exam. The exams will be delivered 10 minutes before the exam hour. Okay, and after you finish, you don't have to print. You do not need to print it. You only need to write the problem number clearly and write your student number, write your name clearly on the answer sheet, and take photos of your answer sheet. And send them back to me. Okay, so you only need to take the photos of your answers and send it back to me. After the scheduled time, your answer will not be counted. So you have to do that really in time. Okay, so that is the requirement. If you have any questions about the exams, the exercise, or you have other questions about the class, you can send me email. Okay? And for this YouTube video, every morning, not every morning, for before each class, I will give you, I will update the video. You will see the new updated, new uploaded videos. So you don't have to, you will watch and study the corresponding material during the scheduled time. Okay, so it's on your duty. You must watch and study. Okay, so my video is going to just help you to understand the material. If you have any questions, you can either read the textbook or you can ask me. All right? Okay, so that's the basic stuff. My email address, yeah. You already have several emails from me, so but still, let me put my email address. I don't have official office hour in this setting, but whenever you have question, you can just send me email. I will try to answer your questions as quick as possible. Okay, so my email address is lin.shen@upr.edu. Okay, so this is the general information about the class, and also consult that Boss-Gayhoff file. That file is also very important. All right. So now let's start our today's class. So today we're going to discuss the review section, review chapter, section 1. Real numbers. Okay, the first review chapter, section 1. So in this section, possibly we just collect the well-known notations and the names. So it is not a brand new section. You possibly know everything I discuss, but still just collect them as a dictionary. Okay? So 1, we work with a set. So what sets? So a set is a well-defined collection of distinct objects. Okay? So a set is a well-defined collection of distinct objects. So this definition actually has two important words. One is well-defined. Well-defined means you will know if an element is in or not in A. You know a number A is in or not in a set A. Okay, so that is well defined. There's no gray area, something you are not so sure. That is not a set. You were pretty sure this is in or out. So that's a well defined. And distinct. Distinct means that any two such, we call this, if it is inside, we call it an element. Any two such elements are different from each other. So when you have a set, you will not repeat element. For example, a set contains 1, 1, 1, 1. That does not happen. Okay? So a set will contain 1, 2, 3, 4. This is possible. All the elements are different. You don't repeat an element. Here, element means the object inside the set. Okay? And sometimes a set contains nothing. If there's no element in this set, if a set contains no element, it is called an empty set. Or null set. And it is denoted by this symbol. So you draw a circle and cross it. Cross it this direction. We always cross it this direction. Okay? So when you see the circle with this segment, it means it's an empty set. It does not contain any element. All right? Okay, so for example, we know the digits. We know those are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. They are digits. And if we want to represent the set of all digits, D is a set of all digits, then D can be written as you use big parentheses, brace, you use the braces, and you put 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The brace, another brace, a pair. Okay, so you see here, you list all of them, but you do not repeat. Remember, you do not repeat elements. Okay, so this is an example about the set. And each digit is called an element. Okay? And this type of a representation for a set is called the roster method. This method of denoting a set is called the roster method. You just list all possible elements. Okay? Okay, so this is a roster method. And of course, sometimes we have other way to represent or denote a set. So we can use so-called the set builder notation. Set builder. Notation to denote a set. So how do we do that? For example, we put D is equal to, we use the brace. Okay, so you put X here and you use this vertical segment. And after this vertical segment, you're going to describe or give the condition of X. X is a digit. Okay, so first you mention the name of the element, it's called x. And second, you mention the property of this element. This element has to be a digit. All right, and this is read like D is the set of all x such that x is a digit. Okay, so that's how do we read it? D is a set of all x such that x is a digit. All right, so this is a so-called the set builder notation. The set builder notation. Okay, so for example, if we put E is a set of all x such that x is an even digit. Okay, E is a set of all x such that x is an even digit. Then you are going to observe that in this is the total, the set of all digits. And among them, you will see 0, 2, 4, 6, 8 are even. So even means it is the bar, in Spanish is bar. It can be divided by 2, right? Even. So if we use this roster method, it's just 0, 2, 4, 6, and 8. Okay? For example, let's have another set. O is the set of all x such that x is an odd digit. Again, you study this total list, you will see odd digits are 1, 3, 5, 7, and 9. So you have two different methods to denote the same set. One is a so-called set builder notation. The other one is called the rosters method. All right. Okay, so after we denote a set, we are going to compare them. So if we have two sets, if you compare, you will compare two sets. So if let A and B be two sets. We have two sets. If every element of a set A is also an element of a set B. Okay, every element in set A is an element in set B. We say that A is a subset, subconjunto. Sometimes I know how to say it in Spanish. I will say it. If I don't know, I will not say it. Okay, so we say that A is a subset of B, and write A subset of B. Yeah, let's so to talk about the language, I can read Spanish. In the exam, you can answer the questions in Spanish, but please write it as clear as possible. My Spanish is limited. If it's not very clear, I may not be able to understand it. So you can answer the questions in Spanish. That's not the problem. And my problem will be possibly in English. If you don't understand, for the practice exam, you just ask me. I will try my best to translate, but I cannot guarantee that all the problems will be properly translated. So English is better than Spanish. Okay, anyway, let's continue. Okay, so we have subset. A is a subset of B. It means every element of A is also element of B. And if A is a subset of B and B is a subset of A, in other words, A, B have the same element, then we say that A is equal to B. They share the same element, A is equal to B. All right, so for example, let's see if we have 1, 2, 3 roster method, and another one 1, 2, 3, and 4. Of course, this set, every element belongs to the second set, so it's a subset of the right side set. Okay, so this is a subset. And 1, 2, 3, and 3, 2, 1, they have the same element. In the set language, we never talk about order. There's no order. You can put 1, 2, 3, 2, 1, 3, 3, 1, 2, whatever order. We just care what elements are inside or outside. Okay, so because of this, these two sets are equal. They share the same identical elements, so they are equal. All right. So subset and equal. And next, not second, definition. So if A and B are sets, then we define the intersection of A with B denoted A cap B is the set consisting of elements that belong to both A and B. So you pick up the element belonging to both A and B and put them together, you construct the intersection. Okay? And the union of A with B denoted A cup B is the set consisting of elements that belong to either A or B. You see, it's a difference about the union and the intersection. Intersection, both. Union, either. Okay? Let's check the example with those intersection and union operations. So let's see, we have two sets, or more than two sets, with three sets. A is 1, 3, 5, 8. B 3, 5, 7. C 2, 4, 6, and 8. Okay, so we have those 3 sets. Let's try to find first problem, A cap B, the intersection. What is the intersection? You're talking about the intersection of A with B. Intersection of A with B. How do we find it? You just see the repeated element. 3 is here, 3 is also here, it is repeated. 5 is here, 5 is here. So only those 2 elements are repeated. 1 is here but not in the second one. 8 is in A but not in B. 7 is in B but not in A. So only 3 and 5, those 2 elements are repeated. So the intersection is a 3, 5. Okay, intersection is a 3, 5. Okay, that's a intersection, cap, A cap B. And second, let's talk about union, A cup B. A cup B, either or. So first, you just copy the first set, 1, 3, 5, 8. And second, you check which element in B are not copied. Okay, 3 is in B, but it's already copied, you don't need it. 5 is already copied. 7 is in B, but not in A, so you add it, you join it. The union, you're going to add the missing element from from B into A. So 7 is missing for A, so you just add 7 to this set, you get a bigger one. So union normally becomes bigger, intersection normally shrinks smaller. Okay, you just get all the appeared elements together, you get a union. Of course, we can have some complex or composition. So we get B intersection with A union with C. It's like the operation of numbers. Whenever you see parentheses, you're going to compute inside operation first. So with this parenthesis, it means you're going to compute the union of A with C first. Okay, so let's check. B intersect union of A with C. A union C, you see 1, 3, 5, 8. 1, 3, 5, 8. This is A. And then let's check C. 2 does not appear, so you add 2. 4 does not appear, you add 4. 6 does not appear, you add 6. But 8 appears already, so you don't do it. You just ignore it. Okay, so this is the union of A with C. So this is a new set. You're going to compute the intersection of B with this new set. B is a 3, 5, 7. Here you check it. You will see 3, 5, 7, and this long list, again, only 3 and 5 are repeated. Even though you add a lot of additional elements, but those elements are not repeated in this B. So the intersection is still 3 and 5. Okay, so again, to talk about intersection or the union among several sets, if you have parentheses, you need compute what's inside first. It's like the computation of numbers. If you have a parenthesis, you're going to compute the internal operation first. All right. Okay, so next, before we can discuss the next definition, let's consider something in our mind. So when we work with sets, we usually designate a universal set. Universal set. So what is universal set? The set consisting of all the elements that we wish to consider. So, for example, when we were kid, we possibly will only consider the positive integers like 1, 2, 3, 4. In our mind, everything will be 1 banana, 2 oranges, 3 apples, something like that. So in our mind, whenever we talk about, okay, let's talk about numbers, they are 1, 2, 3, 4, 5. After you go to the elementary school, after you learn the rational numbers, the fractions, you will see, okay, I know what is 1/2 and what is the 2/3, what is 9/10, something like that. And also after that, you learn what is the negative numbers. So when you talk about numbers, you will think, okay, we have rational numbers, fractions, we have integers, we have positive numbers, we have negative numbers. So that is a universal set. And later, after you go to the high school, you learn some number, so-called irrational. It cannot be written as a ratio of 2 integers, like square root of 2, pi, they are irrational numbers. So in this moment, your universal set becomes the set of all rational numbers, irrational numbers, real number, the integers, positive or negative. So that is a universal. So every time when you talk about the elements, you just preset some scale, like this is the range we're going to discuss. Outside it, we don't consider. That is the universal set. Okay? You want to the element you want to consider. We always assume some universal set there, but sometimes we just don't make it very clear. Okay? So now let's assume definition, sorry. If A is a set, the complement of A denoted A bar is the set consisting of all the elements in the universal set that are not in A. So it is in the consideration, but it's not in set A. That's in the complement of A. We use A bar. Right? So that's our complement. This complement depends on the selection of a universal set. When your universal set changes, your complement will change. For example, let's make the universal set clear when you try to understand the complement of a set. So if the universal set is U is a set of 1, 2, 3, 4, 5, 6, 7, 8, 9. Those digits, but without a 0. And if a set A is 1, 3, 5, 7, 9, all odd digits, all odd digits, then what is the complement of A? It's the complement of A means it's supposed to be in this universal set, but not inside A. So 1, 3, 5, 7, 9, they belong to A. So you're going to have 2, 4, 6, 8. You just get the missing element, you put them together and form the complement. All right, so this is the example. And from this definition of the complement set, we can see that for every set, if you get a union with its complement, it will be the whole universal set. You have some element you want to consider, you have some element, you have element inside A, you have element outside A, then the total will be the whole set of a considered element. So A union with A bar is equal to U, and A intersect with A bar is equal to empty set, because it clearly say the element is not inside A, then it is inside the complement. It's either inside or outside. Inside A cannot inside complement. Inside the complement cannot inside A. Right? Sometimes those languages may not be very clear, so the people invented so-called the Venn diagram. So what is a Venn diagram? Venn diagram means we use a rectangle to demonstrate the universal set. So this whole thing is a universal set. We only consider the region inside the rectangle. And then we draw the circles. It's a set A. It means element totally inside this circle A. If you have another set, it will be B. Or you have a third set, it will be C. So this is so-called Venn diagram. Venn diagram, with the help of Venn diagram, let's see what is a subset. Subset A is a subset of B. By definition, it means every element of A is also an element of B. So you're going to draw a small circle A, and you're going to draw the large circle B, totally surrounding this A. This is a subset demonstration. Element of A is inside B. If two sets have no intersection, you have set A, you have set B, they don't overlap, then we know that their intersection is empty. There's no overlapped part. Okay? And what is the intersection? You have set A, you have set B, and this is intersection. It's overlapped region, intersect B. Right? And let's see what is a union. With the Venn diagram, what is a union? Union. You have set A, you have set B. Just get the whole region covered by A and by B together. So this is a union B. What is a complement? Inside is A, then outside is A bar. Okay, so this is a complement. You have inside, outside. Okay. Okay, so this is a set theory. We get this set numbers, set notations. We have sets. What is a set? What is a union, intersection, complement, and universal set? Of course, you see here, if I draw this universal set like this size, then the complement is this. I can, of course, enlarge this universal set, then you will have a bigger complement. If I shrink the universal set, you have a smaller complement. So the complement depend on A, also depend on the universal set. Okay, so that is a set. Now let's really talk about numbers, classify. Classify numbers. First, we have 1, 2, 3, 4. There's no end. You can just count them. They are either called counting numbers or natural numbers. So sometimes you will hear natural number. Natural number just means 1, 2, 3, 4, 5. Okay. If you want to add a 0 there, if you include a 0 in this set, this is called whole numbers. Zero is not a natural number, but the 0 is still a whole number. It represents nothing, but still it's a whole number. Okay? And then we say the integer are the set, the integers are the set of numbers. The integer will have a positive and negative. Counting number or natural number has one infinite end, but integers has two infinite ends. It is infinite for the negative part, it is also infinite for the positive part. Okay? And after we learn the integers, we learn the fractions or rational numbers. A rational number is a number that can be expressed as a quotient A over B of two integers. Okay, so rational numbers means the ratio of two integers. The one on top, A, is called the numerator. And the number on the bottom, B, is called the denominator. And we know that B cannot be 0. 0 cannot be denominator. okay, the numerator over the denominator, right? And the rational numbers are the numbers in the set x such that x is equal to a over b, where a, b are integers, b is not equal to 0. Correct? Yeah. Okay, so this is integers and rational numbers. And after the rational numbers, we also know some number which is not rational. For example, pi. Pi cannot be written as a ratio of two integers, so they call irrational numbers. The irrational numbers cannot be written as a ratio of two integers. If it can be written as a over b, then it is rational. Here it's a irrational numbers. It's not that easy to clear one number is rational, irrational, but we do have some examples. We know that pi is the first well-known irrational numbers. It's approximately as a 3.14 with additional numbers, but it's not equal to 3.14. It's just approximately. And we also know that the square root of 2 is irrational numbers. And square root of 3, square root of 5, whatever square root number, so that the internal number is not a perfect square, it's irrational. So when square root of 4 is equal to 2, that is rational, but square root of 2, 3, square root of 5, square root of 6, square root of 7, square root of 8, they are all irrationals. All irrational. But they do not list all possible. There are many others. Okay? Okay, so after we have natural numbers, whole numbers, you see, we have a natural number. One, two, three, four. And then we have a whole number. We add zeros. And then we have integers. We have negative, we add negative numbers. Then we have rational numbers. We got the ratio. And together we also have irrational numbers. This is separate. It's not included. This rational, irrational, they do not have intersection. Their intersection is empty set. So we put all these rational, irrational together. We call them real numbers. Okay, so that's a definition. the set of real numbers is the union of the set of rational numbers with the set of irrational numbers. Okay. Okay, so in the textbook, they provide a Venn diagram. Venn diagram is like this. So the left irrational, right rational. Okay, so the whole set is the universal set is a real number. The real number is rational, irrational. Rational, irrational, they have empty intersection. In other words, the complement of rational is irrational. The complement of irrational is rational. Okay, they are complement to each other. And inside the rational, you will have integers. Inside integer, you will have the whole numbers. Inside the whole